integration by parts and U-substitution for definite integrals. In this video, we will learn how to calculate definite integrals using the two main integration methods, integration by U-substitution and integration by parts. The principal step in the evaluation of a definite integral is to find the related indefinite integral or the antiderivative. If you need to review this subject, please watch the videos posted in the upper right corner of the screen. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It's very important for the continuity of this channel. When we use the substitution method for evaluating the definite integrals, we follow the steps. Make appropriate substitution to reduce the given integral to a known form to integrate. We write the integral in terms of the new variable. Integrate the new integrand with respect to the new variable. Change the limits accordingly and find the difference between the values at the upper and lower limits. Let's solve the following example to make the substitution method for definite integrals clearer. To solve the integral, we introduce a new variable t, such that t equals 2 times x minus 1. If t equals 2 times x minus 1, then differentiate t to find the t and solve for the t. Doing this means that the function we must integrate becomes square root of t over 2. This certainly looks like a much simpler function to integrate than square root of 2 times x minus 1. The new function of t must be integrated with respect to t, not with respect to x. But the original limits of integration are limits on the variable x, not t. When we integrate with respect to the variable t, the limits must be written in terms of t too. So we use the substitution to find the limits of integration. When x equals 2, t equals 3. And when x equals 6, t equals 11. We now evaluate with t at the upper and lower new limits and subtract. There is no need to convert from t back to x. Integration by parts for definite integrals. The integration by parts technique is the same for both indefinite and definite integrals. We just add one step to calculate the integral at the upper and lower limits of integration. Let's solve the following example to make the integration by parts for definite integrals clearer. We let v equals to ln of x, then dv equals to 1 over x dx. dt equals to x dx, then t equals x squared over 2. We now use the formula for integration by parts to obtain. We now apply the fundamental theorem of calculus. Try to solve the next examples by yourself. Then check the answers. The examples are solved step by step.